Audio Jungle.
If you consider the data is being generated at large magnitude, when I talk about the backend, the data warehouse and ETL processing, and the large databases to store the huge magnitudes like Teradata, Netager, and purchasing the storage from SAN, all these things are making the data storage and processing. It is too expensive, and we need an alternative. That is one and only Hadoop. Of course, this is not so simple as we talked about because we can't change all your infra overnight. So in order to change this, there should be several drawbacks in the existing data storage and processing methodologies. Because the simple word like Hadoop, we can't change your infra. So there must be several drawbacks in the existing data storage and data processing methodologies. Let me just share what are all the drawbacks. Consider you have a bank account which is open somewhere around 2000. After 14 years, in 2015, you approach the bank and you ask to them for past 3 months bank statements, which you will get hardly a couple of minutes or at least half an hour of time. Consider the very next day you approach the same bank and you ask them for past 10-year bank statements, which you can't expect the same span as you got your 3 months bank statements, because all your data will be moved to the backend, from which they will start generating some reports. It is very much crucial for organization development. In this process, storing your data, processing your data, there are several drawbacks. Let us just discuss what are all those drawbacks and why we need an alternative and why that alternative should be Hadoop. Let me just talk about data storage and processing literature survey. We know the data is too precious. We classified the data as people's data and machines data. When I talk about the people's data, we the people usually uploading images and social networking sites like e-commerce, online shopping, online reservations, and banking sector, we usually generated some data. And we the people generally uploading images, videos, likes, comments, shares, tweets, whatnot, everything and all the stuff we generating the data. And machines also generated data like RFID readers, sensors, GPS traces, satellite communication, and your mobile phones, system log files. These are all comes under the machines data. Where the challenges initially, organizations like Google, Yahoo, Amazon, Facebook, because these are all the guys who usually with a large magnitude of data. But now this is the problem to almost 90% of the organizations. They are just suffering from large magnitude of data. They don't know how to handle that. And not only simple magnitude, there are several other factors with your data also. In at last, I passed a bold statement stating that existing methodologies were becoming inadequate to process such large data sets. Let me start the journey, the data storage perspective. When I talk about the data storage, the first and foremost word that will strike away your mind is nothing but RDBMS, which has been ruling the industry from past 2 decades, but where RDBMS have several drawbacks. Some of them are like, there is a storage saturation limit where RDBMS can't hold or perform well with large magnitude of data. We can't store terabytes of data. And schema on right. Whenever you want to upload the data in RDBMS initially, you need to define the schema. And if you get any new field other than you defined, you can't store that, obviously. So you need to know what sort of data you will get in future. And if you get anything other than that, you can't store that. So that is one of the drawbacks. And above all, DAS, NAS, SAN, there is no support for unstructured data, which is the most sounding stuff. Let me just share what exactly unstructured data is. The data in which you can't design any schema comes under the unstructured data, where XML files, HTML files, log files, images, audio files, video files, all these comes under the unstructured data. But it is quite unfortunate, about 90% of the data which is being generated unstructured data, where your RDBMS fails at this perspective. This is just regarding the storage in RDBMS. But when we talk about the physical storage of disks, we usually purchase SAN storage, in which we have been storing the data in FC disks, fiber channel disks. And the latest enhancements are SSDs, solid state disks. So the word SAN, it is too expensive because we use switches in the SAN. It is expensive, and fiber channel cables for expansion. And not only storing your data, usually you need to provide the redundancy, backup. Simply backup for your data. By using RAID levels, we have 0 to 9 RAID levels. By using 0 to 9 RAID levels, we are creating a backup for your data. So finally, number one, on an average, you can't store unstructured data. Number two, the hardware is too expensive. The hardware is too expensive. Let me just share what about the data processing challenges. When I talk about the data processing, obviously storing your data, after storing the data in RDBMS environment, usually you need to transfer the data from storage area to processing area, where you are using Teradata and Netager, these type of technologies. Here when we talk about Teradata is very good approach to process your data and to store large magnitude of data. But Teradata, it has drawback. Though Teradata can process the data in parallel way, the block size of the Teradata, it is only 16 KB, which is very less. And above all, it will not work with normal hardware. They will require hand hardware like blade servers and Spark processors to work on. And here I need to talk about the RAM. It's also become a high-end hardware. The largest RAM so far available, it is 128 gig. The data storage, we already discussed. It's not support for unstructured data, and it is expensive. And the same expensive comes into the processing picture as well. Because we need high-end hardware, it is too expensive and it can't support unstructured data. So here also the hardware, it is too expensive. Number two, it can't support unstructured data. Let me just talk about network constraints. Because the word network itself indicates the several drawbacks. And currently we are using FC cables, fiber channel cables for expansion, and FC cables for transferring your data, like one place to another place and machine to machine communication. There we are using FC cables, fiber channel cables, which we could acquire transfer rate. It is 16 GB per second or 10 GB per second. Maximum in production environment we are using 10 GB per second transfer rate, as well as 16 GB per second at most. I think 16 GB per second transfer rate is not a simple transfer rate, it's huge. Though your network could able to 16 GB per second at largest speed, but your disk can't read that much faster. At this perspective, I need to talk about a simple word is called disk seek time. Disk seek time. Though your network could able to transfer the data at this most 16 GB per second, but the disk hardly at 250 to 500 Mbps only. So obviously you got a bottleneck problem. And we usually use Linux or Unix flavor for storing your data. Let us consider we have a lot of Linux flavors are there, like Red Hat, Ubuntu, Sun Solaris, CentOS. We have approximately a lot of Unix flavors, but these are the familiar. And usually we are using Linux or Unix flavor for storing your data. Let us consider my Linux operating system block size. It is 8 KB. My Linux operating system block size is 8 KB. Let us consider I have 64 MB data. If I want to store 64 MB data into my Linux operating system, here internally it consumes 8000 blocks. It will internally consumes 8000 blocks. When in order to retrieve same 64 MB data, a disk head need to be moved 8000 times from one block to another block. Your disk head need to be moved 8000 times from one block to another block. The time taken by a disk head move from one block to another block in order to retrieve the data back is nothing but disk seek time. And after all retrieving 64 MB data, my disk head need to be moved 8000 times. What about terabytes? What about petabytes? What about zettabytes? And what about exabytes? Obviously it will take more time. So here also on an average, number one, we got a bottleneck problem. Number two, we got a disk seek time. Till now, I didn't spell any word about Hadoop. I just raised the drawbacks of existing storage, processing, and network scenario. This is the diagrammatic representation what we discussed till now. See, I have unstructured data. Number one, our existing methodologies, they can't support unstructured data, both storage and processing scenario. And the hardware, it is too expensive. The hardware is too expensive. Number two. Number three, the transfer rate is too huge when compared to disk speed. Obviously, we got a bottleneck problem. Number four, we have a disk seek time. The block size is too small when compared to data. So obviously we got a disk seek time. So we need an alternative. That alternative should be support unstructured data. We need an alternative. That alternative should be support cheap commodity hardware, not like high-end hardware like blade servers and Spark processors. We need an alternative. That alternative should be overcome the drawback of bottleneck problem. And we need an alternative. That alternative should be overcome the disk seek time. So that alternative is one and only Hadoop. Clear till now? And before going to Hadoop, I want to share some useful information with you. This is the most important. Why? Because the main reason why I have much focusing on data much here is, I think you're the guys heard the organization IDC, International Data Corporation. The work of IDC is to analyze entire world's digital data. Actually, it's not very easy to analyze entire world's digital data, but the work of IDC, it analyzes entire world's digital data. According to IDC, in 2006, the world's data is in 0.1 zettabytes. In 2011, the world's data is in 1.8 zettabytes. See, I just gave the magnitude here. 1024 gigabits equals to 1 terabyte. 1024 terabyte equals to 1 petabyte. 1024 petabyte equals to 1 exabyte. 1024 exabyte equals to 1 zettabyte. And 1024 zettabytes equals to 1 yettabyte. If you observe that, in the span of 5 years, the data increases 10 times. 10 times is not a simple figure, right? The data increases 10 times. By the end of the 2020, the world's data reaches to 40 zettabytes. According to IDC estimation, by the end of the 2020, the world's data reaches to 40 zettabytes. Where this data comes from? What are the sources? Millions of apps are running every day. Day by day, the technical growth is too high. Right? Millions of apps are running. Millions of the people, they have a Facebook account, Twitter, like social media websites. Sensors, GPS traces, satellite communication, and system log files, mobile phones, everyday bank transactions, whatnot. Each and every electronic device generates some data. Each and every electronic device generates some data. Right? These are the sources of the data. So it is a big trouble. So we need an alternative. And 80% of the organizations, they are generated unstructured data. I classified the data as structured, unstructured, and semi-structured. You know structured data? The best example for structured data were employee information simply. You can design a particular schema by using SQL. Like a table name, ID, string, like that. ID, int, name, string, like this type of structure. When we talk about unstructured data, the best example for unstructured data are our images, audios, videos. These are all comes under unstructured data. You can't design any schema on it, simply. And semi-structured data, it is 50% structured, 50% unstructured. 50% structured and 50% unstructured. The best example for production data is web server logs and email. When we talk about email, you have two CC, BCC, subject and text body. When we talk about our email, you have two CC, BCC, subject and text body. And here, when we talk about two CC, BCC, these three fields, if you observe that, these three fields maintain only mail format like xyz at gmail.com, at yahoo.com, at xyz.com, like that. If you enter any number, symbol, character, it won't accept. Why? Because it follows some structure. It is mail format. And when we talk about subject and text body, these two fields, you can enter any number, symbol, character, whatnot. Anything you can do. It will accept. So, it is 50% structure and 50% unstructured. Simply you can call semi-structured data. right? So I classified the data as structured, unstructured, and semi-structured. Now we will discuss about the big data. Big data. It's not a technical term. This is the hot cake in the market currently. Any data having several characteristics could be spelled as a big data. Let us just discuss what are all those characteristics and all the stuff. The best example, see. Here, I'm just asking to some ex-person how much data you have. Then he said, I have 10 terabyte movies. Fine. And I'm just again asking to some Y person how much data you have. He said, I have 100 terabyte employee details. And again, I'm just asking to some Z person how much data you have. He said, I have 10 terabyte web server logs. If you observe here, for all the people, they are just to spell the word commonly. The size, 10 TB, 1 TB, 100 TB, 200 TB. That is the size. Simply volume, more than terabyte. They said they spell the word variety. It is simply the data type, like whether it is structured data, unstructured data, or semi-structured data. And velocity, simply the transfer rate. The data, the rate at which you need to process the data, that is the transfer rate. Simply documents maintain some transfer rate, videos maintain some transfer rate, images maintain some transfer rate. It depends on your data type. If your data maintain these three characteristics, simply you can call big data. That data must and should the volume is in more than terabyte. If you have less than terabyte, it is simply you can call small data, not like big data. Okay. Our existing methodologies, they can't hold or perform well with large magnitudes. So we need an alternative, that is one and only Hadoop. Now we will discuss about Hadoop. Hadoop, it's not a technical term. Not at all technical term. It's a toy name. That toy is yellow stuffed elephant, so that's why the Hadoop logo comes with yellow elephant. Hadoop is not a technical term, and this is not any web application, and this is not any desktop application, this is not any operating system. Hadoop is a framework. When we talk about Hadoop, here we have two core components. One is for storage, another one is for processing. When we talk about storage, we have HDFS, Hadoop Distributed File System. Hadoop Distributed File System. I think you know distributed file system is not new, it's old. Hadoop Distributed File System is new. Why? Because Hadoop Distributed File System default block size, it is 64 MB. The default block size 64 MB. See, as per our previous example, 64 MB block size is not a simple block size. Even it is configurable. You can configure 128 to 256, 1 MB, 2 MB, 3 MB, 4 MB, your wish. As per your requirement, as per your client requirement, you can configure as per your data size. See, as per our previous discussion, I have Linux operating system, whether it is Sun Solaris, SUSE Linux, Ubuntu, Red Hat, CentOS, whatever it is. I have Linux operating system. I stored 64 MB data into my Linux operating system. Internally, it consumes 8,000 blocks. Why? Because here block size is 8 KB. When in order to retrieve same 64 MB data from my Linux operating system, my disk head need to rotate 8,000 times. 8,000 times. Same 64 MB data, if you stores in HDFS, it stores internally, it consumes single block. Whenever you retrieve the data, obviously your disk head need to rotate single time only. So obviously the disk latency is gone, right? So HDFS, Hadoop Distributed File System, it is the responsible service for storage and processing. When we talk about processing, here we have MapReduce. MapReduce, one of the mechanism for massive parallel processing, and as per your requirement, you need to just design simple MapReduce program and submit this code towards your storage. Few KBs or MBs you need to pass over the network. You don't need to move the data from storage box to processing area. You are just moving few KBs maximum in MB code over the network towards your storage, right? So finally, in Hadoop we have two core components. One is for storage, another one is for processing. And Hadoop can make data storage and processing at one hub. And this is not my declaration, this is IBM declaration. According to IBM declaration, see, they processed 1 TB unstructured data by using RDBMS technology. It consumes 28 hours of time. Same 1 TB unstructured data they processed with Teradata technology. It consumes 7 hours of time. Same 1 TB unstructured data they are processed with Hadoop on latest enhancement. With Hadoop it consumes on 180 node cluster. It consumes 3 minutes 43 seconds. Same 1 TB unstructured data they are processed with the latest enhancement of Hadoop, that is YARN architecture. It consumes 1 minute 14 seconds. See how Hadoop process your data. So here this is the internal architecture of Hadoop. See, you can get more clarity here. If you observe that as per our previous discussion, in existing methodologies total we have 4 drawbacks. Number 1, you can't store unstructured data. Number 2, the hardware is too expensive. Number 3, we got a bottleneck problem. Number 4, we have a disk seek time. So all these 4 drawbacks overcome by Hadoop. See, as per our previous discussion, in Hadoop I have 2 core components. One is HDFS and another one is the MapReduce. When we talk about HDFS, default block size is 64 MB, right? Let us consider, just for easy example, I taken 640 MB data. 640 MB is too small. It's not a huge data set. Just for easy example, I taken 640 MB. If I want to store 640 MB data to my Hadoop cluster based on my block size, the data split it as blocks like this and scattered across the cluster. Obviously 640 MB data split it as blocks, that is 64 into 10, 640 MB, right? So all these blocks scattered across the cluster. Total overall 10 blocks are there. Cluster means, you know, group of computers, right? And here my data split it as blocks and scattered across the cluster, and as per my requirement I want to design simple MapReduce program with any one of the language like Python, Ruby, Perl, Java. You can use any one of the language and design the MapReduce code and submit that code to all computers. Each and every computer, by using MapReduce mechanism with the help of JVM, it processes your data individually. All the machines, they are processed your data itself generates final output by using MapReduce mechanism. Here Hadoop, it supports unstructured data and huge data sets. So one drawback is overcome. And here the block size, it is configurable. 64 MB block size is not a simple block size when compared to 8 KB. It's too huge, even it is configurable. Obviously we can't get any disk seek time. And here Hadoop, it supports completely cheap commodity hardware like our 4 GB RAM, 8 GB RAM, quad core processors. You don't need to purchase high-end hardwares. And number 4, you are moving the code towards the storage boxes. You are not moving the entire data set from storage area to processing area. Simply, it can't get a bottleneck problem. So 4 drawbacks are overcome by Hadoop here. And Hadoop, it is very easy to move computation rather than moving data. And it is massive parallel processing for ease. And Hadoop, it is very easy to deal with small data rather than big data sets. And Hadoop, it is completely works on cheap commodity hardware. You don't need to purchase high-end hardware. Right. And see, I think you heard about these supporting tools. HDFS and MapReduce. We just discussed HDFS for storage, MapReduce for processing. If you are familiar with Java, just design simple MapReduce program. If you are familiar with SQL, I don't know the Java. I don't have any knowledge on Java. I'm well versed with SQL. Simply you can go through Hive. I don't know the SQL, I don't know Java coding. I'm well versed with scripting background. Yeah, sure, you can go through P. So here we have a lot of tools are there. These are the familiar tools. Zookeeper, this is for server coordinator. Flume, weblog collector. Scoop for data import and export. Woozy is the workflow engine. Mahout for machine learning. HBase, this is one of the NoSQL database. Ambari, this is for monitoring the cluster. So here, these are the supporting tools. And if you learn Pig and Hive, simply you can call Big Data Analyst. These are the ETL components, ELT tools, simply here. Right? And we have a lot of distributions are there. Here, you heard about Apache Hadoop. Apache Hadoop is completely open source. Anyone can download and anyone can use it. Anyone can download and anyone can use it. No need to purchase license agreements. And based on this open source, one rest of the distributions like Intel organization, it have own Hadoop distribution. It is Intel Hadoop. And Cloudera is one of the Hadoop distribution. Mapr, this is one of the Hadoop distribution. Teradata Hadoop is called Aster Data. Microsoft Hadoop is called HD Insights. Amazon Hadoop is called EMR. IBM Hadoop is called Big Insights. Hortonworks is one of the Hadoop distribution. EMC Square is Hadoop is called Greenplum. HP Hadoop is called Vertica. The major variation between all these distributions are nothing. Whatever you design the code, you can execute on Apache as well. You can execute on rest of the distributions. The major variation is UI and privacy policies and supporting teams like that. Simply, the major variation is UI, user interface.